Froggy. I am going to be going over our first section of this online class, 8.6 standard form. This is the last section that we did in class last week, but I will be doing it again in case those of you missed it or you just want a refresher and so we know where to pick up from. So today we're going to be focusing on standard form, which is ax squared plus bx plus c. We're going to be exploring a baseball problem and graphing the path of the ball so that we can rewrite a quadratic function in vertex form to standard form. I'll know I have it when I can determine what graphing information each form gives. So number 1 says a high school baseball player throws a ball straight up into the air for his math class. The math class will be able to determine that the relationship between the height of the ball and the time since it was thrown could be modeled by the function h of t equals negative 16t squared plus 96t plus 6, where t represents the time in seconds since the ball was thrown, and h represents the height in feet of the ball above the ground. What is the domain or the input of this function? The domain or the input of this function is going to be the total time that the ball has traveled. So if we picture a graph, I'll open up Desmos here. So our equation was y equals negative 16t squared plus 96t plus 6. So this was the graph that we talked about in class last week, and the x-axis represents the total time, and the y-axis, or how high it is, represents how high the ball went. So if we look at these two x-intercepts, remember when the person threw the ball had a starting height. So at time 0, the height was 6, and whenever the ball hit the ground, that's that far right point, 6.062. That means after 6.062 seconds, the ball hit the ground. So we'll say the time is from 0 seconds to about 6 seconds. That's going to be our domain. We'll represent that as 0, 6.062. Again, we're going to use brackets because it's included. The range is going to be how high up and down it is. Obviously, the lowest point is going to be 0 feet, and the highest point the ball gets to is 150 feet. So we're going to say 0, 150. What is the time when the ball is thrown? That's going to be 0 seconds. What is the starting height of the ball? The starting height of the ball is going to be that y-intercept. Whenever you hear the word starting point, you should think of y-intercept. And on my graph, that was at 6 feet. So at 0 seconds, it was 6 feet. 6 feet. What is the vertex of the parabola? How did you determine the vertex? The vertex is going to be at the very top since it is an upside down parabola. Since it is upside down, that also means that this vertex represents a maximum. So these two numbers mean in 3 seconds, the ball has reached 150 feet above the ground. 3, 150. The maximum height is going to be 150 feet. And it took the ball 3 seconds to achieve that. To graph the equation, we did that on Desmos already, and in class I told you how to calculate these by using the function notation. So if I want to calculate after 0 seconds, I'll replace t with 0 because t stands for seconds. So this would be negative 16 0 squared plus 96 times 0 plus 6, and that equals 6. So we know our y-intercept is going to be 6. And I have other points here, like h of 1 equals negative 16 times 1 squared plus 96 times 1 plus 6. I believe that equals 86. I can do it for 2, 3, 4, 5, 6, and 7. I know that at 3 seconds, it was 150 feet. So I know h of 3 is 150. And that's also going to be my vertex. So 3 seconds, 150 feet. It's going to be right here. And since that's also my vertex, I know that my line of symmetry goes through it. Try to center that as much as possible. That looks pretty good. And now I can also use symmetry to graph other points. So this first point over here, that's 3 units away from the line of symmetry. So if I go over to the 6, I should have another point there because it's symmetric. Same thing with this point. I'll know that since that's 2 units away, I'll have another point 2 units away. So I know at 5 seconds, it will be the same thing as it was at 1 second. So this should also be h of 5 should be 86. H of 6 should be the same thing as h of 0, which is just 6. Okay. We're not going to go to 7 seconds because if you recall our domain only goes up to 6.062 seconds, so it doesn't make sense to talk about anything after that. Okay, and we are going to graph it as best as we can. My parabola is not perfect, but as long as it's going through all the points and we know that it's a parabola, that's good enough. Approximately when does the ball hit the ground? At about 6.062 seconds. The domain represents the time the ball was in the air, and the range represents the height of the ball. Okay. Quadratic in the opening explanation was in standard form. What features are visible when it is presented in standard form? Well, when it is in standard form, we know that this c value is our y-intercept. So in other words, f of 0 equals that c value. We also know the concavity, and that's going to open downwards because a was less than 0. In other words, that leading number was negative. What features of a quadratic function are visible when it is in vertex form? Well, we also know concavity. So that's going to be like that, concavity. And we also know the vertex. That's going to be h comma k. A general strategy for graphing a quadratic function is talk about concavity, talk about the vertex, the y-intercept, and the x-intercepts. To graph the function nx equals x squared minus 6x plus 5 and identify the key features, well, we know since it's in standard form, we know our y-intercept is going to be 5. Okay. To calculate the x-intercepts, so let's write that down, y-intercept 0, 5. The x-intercepts, we're going to use the x method, where 5 goes on top, negative 6 goes on bottom, and our two numbers that we're going to use are negative 1 and negative 5. So we get this form, x minus 1, x minus 5 equals 0. The reason we set it equal to 0 is because we're solving for our x-intercept. And if we have an x-intercept, that's of the form x1, 0. Okay, so we're using that zero product property, and we get x equals 1 and x equals 5 for our two intercepts. So here's 1, here's 5. Okay, and we also know concavity is going to be upwards since this is positive. We know that since we have our two x-intercepts at 1 and 5, that our vertex and our line of symmetry are going to be through x equals 3 because a parabola is symmetric. So since we know our vertex has an x coordinate of 3, I can plug that in to figure out the y coordinate. So if I take my function x squared minus 6x plus 5, and I replace x with 3, I should get the coordinate of my vertex. This will be 9 minus 18 plus 5, which equals -9 plus 5 is -4. So my vertex will be here. And again, by symmetry, I'll know I have another point over here, and there's my parabola. For each exercise below, rewrite the vertex form into standard form and then identify all important features. So to change it into standard form, we need to FOIL everything out or use our box method. I'll use box method for this. I get x plus 6, x plus 6, x squared, 6x, 6x, and 36. I have two like terms here. So my reduced form is x squared plus 12x plus 36. Don't forget I have this minus 4. So my final answer will be x squared plus 12x plus 32. So now I have vertex form and standard form. In vertex form, I know right away my vertex is going to be -6 because it's the opposite of whatever's in there, comma -4. The y-intercept I'll find out from my standard form. That's going to be 0, 32. Does the graph open up or down? It opens up because this term is positive. 1x squared, this is greater than 0. And the axis of symmetry is going to be x equals -6 because it goes through the vertex. And the x-coordinate of the vertex is there. I'll use different color for that so it's not the same. There. Okay. Number 7, same idea. Let's start off with that box method. X minus 1, x minus 1, x squared minus x plus 1. Again, I have those like terms. So I get x squared minus 2x plus 1. And then I have this minus 7, not to forget about that. So my final answer is x squared minus 2x minus 6. My vertex will be +1, comma -7. My y-intercept will be 0, comma -7. No, not -7. It will be -6. -6 because in my standard form, that's where I get my y-intercept. The graph opens upwards, and the axis of symmetry is x equals 1. Last problem, we have vertex form. Let's do box method. X minus 3, x minus 3, x squared minus 3x plus 9. I have these like terms. Let's combine them. I get x squared minus 6x plus 9. Notice I have a negative sign here, so I need to add a negative sign in front. What this negative sign does is it changes the sign of everything in parentheses. So this will give me -x squared plus 6x minus 9. And then let's also not forget this plus 2 at the end. So my final answer will be -x squared plus 6x minus 7. My vertex will be 3, comma 2. Y-intercept is going to be 0, comma -7. The The graph opens downwards this time because of this negative sign. And my axis of symmetry is going to be x equals 3. Okay, so we have solved all those problems. Let me go through the lesson summary, and that will be it. So the standard form of a quadratic function is f of x equals ax squared plus bx plus c, where a is not equal to 0. From the standard form, you can easily see that the y-intercept is at c. A general strategy for graphing a quadratic function from the standard form: look for hints in this function's equation for general shape, direction, and y-intercept. Use a t-chart to find more points on the graph. Remember that a parabola is symmetric about the vertex. This can help you identify other points you may need. And plot the points that you know at least 3 are required for a unique quadratic function. Sketch the graph of the curve that connects them and identify the key features of the graph. And that is it for lesson 6.